So in this video, I'm looking at DEB 2017 Leaving Cert Higher Level Maths Paper 1 Question 4. A curve is defined by the equation x minus 3 squared plus y squared is equal to 25. Find dy dx in terms of x. Okay, so I want to first get y is equal to something with x's. If I'm going to find dy dx, I first need the y on its own. So I'm going to subtract x minus 3 squared from both sides and multiply out this right hand side and simplify it as much as possible. I'm then going to try and find y on its own. So what's the opposite of y squared? Would be a square root. So that's why I'm going to square root both sides, coming from here to here. But when introducing a square root, it's important that I introduced a plus and a minus. So when I've introduced the plus or minus because it is a square root. When you're introducing a square root to a question, you must include the plus or minus. Okay, then I've changed it to a power of a half, because with differentiating, it's so much easier to differentiate when it's to the power of a half, but it's the whole bracket. When differentiating and it's the power of a fraction, a big fraction like this, we need to use the chain rule. So the rules for the chain rules here, we're going to bring down the power, keeping the plus or minus, leave the bracket alone, reduce the power, so now it's minus a half, and then differentiate the bracket. Okay, so I've differentiated the bracket there. Tidying up is then the next step. Okay, in tidying up, I'm going to leave the plus or minus a half out the front. I'm going to change this to be 1 over, and it could be 1 over minus x squared plus 6x plus 16 to the power of a half, but I also note that a power of a half can be written as a square root. So page 21 of your log tables will tell you negative power, it could be written on the bottom line of fraction. It'll also tell you power of a fraction. It can be written as a third. And then I've changed minus 2x plus 6 to be over 1, which doesn't really change anything. Simplifying it by bringing it all together, top by top, bottom by bottom, and then the 2 divides into the top line nicely as well with the plus or minus. Now, very few times you're ever going to come across a situation where there's a plus or minus in your answer there. And I want to show you why there's a plus or minus in my answer. You can see that I've, for the next part, just rewritten down the equation again. And you might notice that the equation is the same as the equation of a circle. It's a circle that they've given us. So we know the center is 3, 0 is the center, and the radius is going to be 5. So the center, it looks something like this. You know, it's not great, but the center is, it's on the x-axis. This point here is 3, 0. So think of the point 6,4. The point 6,4 is going to be out here, isn't it? And they want us to get the tangent of that. It's going to be sloping downwards in that section. But imagine if they'd asked us to get this tangent. It would be sloping upwards. So that's why dy dx has a plus or a minus. We're going to take the minus one because obviously we want the purple at 6,4 where it's sloping downwards. So I want the slope then. Dy dx, remember, represents the slope. I want the slope, it's going to be minus x plus 3 over the square root of minus x squared plus 6x plus 16. I want it when x is equal to 6. So dy dx is equal to minus 6 plus 3 all over the square root minus 6 squared plus 6 by 6 plus 16. Dy dx is equal to minus 3 all over, simplify this bottom line, the square root of minus 6 squared. Now it's not the minus that's being squared, it's just the 6 plus 6 times 6, which would be 6 squared, plus 16, so we're going to end up with 4 here. Yeah, square root of 16 would be 4. So m, the slope, is equal to 3 over 4. And then we want to find the equation of the tangent. You're going to use y minus y1 is equal to n by x minus x1. Y minus 4 is equal to 3 over 4 by x minus 6. 4y minus 16 is equal to 3x minus 18. 3x minus 4y minus 2 is equal to 0. So hopefully you get that about the slopes. If they asked us about a point down here, we'd use the positive one. If they asked us about a point down here, we'd use a negative one. So little diagram, really helpful here. Show that the curve y is equal to 2 over x minus 3, where x is not equals 3. Why would x not be equal to 3? Because if x was equals to 3, the bottom line would be 0, and then the world would explode. So remember, we can never have 0 on the bottom line of a fraction. We can never divide by 0 or the world explodes. That's talking about vertical asymptotes there. The vertical asymptote is x is equal to 3. So sort of bringing functions in here as well. To show it has no turning point. Well, if it has no turning point, it's either it's always increasing or always positive or negative. It's dy dx is always positive or negative. Dy dx is always positive or negative. So let's go and find dy dx. A second way of doing it would be to go and try and find, well, where is the turning point? How do you find the turning point? So I'll do both options. How do you find turning points, max and mins generally? We normally set dy dx equals to 0 and then solve. So we'll do both options. We'll do the blue option on the right, so we'll find dy dx first. Dy dx is equal to, so we're going to need to use the quotient rule, so it's x minus 3 times 0, so u is equal to 2, v is equal to x minus 3, du dx is equal to 0, dv dx is equal to 1. So it's v, which is x minus 3, times 0 minus u by dv dx, which is 1, all over v, which is x minus 3 squared. And I'm going to set that equals to 0, so I'm getting minus 1 over x minus 3 squared is equal to 0. So you're saying minus 1 is equal to 0. Well, that doesn't work, so therefore no turning point. Or we can look at it and go, okay, well, let's show that it's always increasing or decreasing. So again, we're going to find dy dx. Dy dx is equal to, so the u again is, or sorry, the v is still x minus 3. The du dx is 0 minus u, which is 2 by 1, all over x minus 3 squared. Dy dx is equal to minus 2 all over x minus 3 squared. And I suppose it's worth noting this is always negative and this is always positive. So the slope is always, how come the bottom line is always positive? Because anything squared is always a positive number. So minus over positive, always negative. So the slope is always negative, and it's actually curious that this whole bit is good enough for both. If you rewrite it again, you just had to rewrite it again and put it down here. So always negative, therefore no turning points. Okay, comment on the shape of the curve. It's always sloping down. So again, like a quick little sketch of what it might look like. We know it's not allowed to be equals to 3. So this is the vertical asymptote. X is equal to 3. It never crosses that line, and it's always sloping downwards. So it's that way, and it never hits that line. It never hits that red line, always sloping down. Or it's like this. Yeah, always sloping downwards.